once again, welcome everyone to what is our 23rd Coffee with EMBL event. We were just reflecting on the fact that this has indeed been 23 times that we've organized these online discussion events, and we're very excited that what started off as a one-off attempt to bring the community together in April 2020 to help us all face up to the problems of the COVID pandemic has metamorphosed into a vibrant online chat forum where we can come back together on a regular basis. I think this idea of doing it every 3 months is working well, and give us a chance to catch up with the events and discuss important topics. Today, the topic that we're going to focus on in its many aspects is leadership, and how leadership is evolving in science in different categories. Once again, this is an interactive event, so we encourage everyone to post comments, discussion points, and if you would like to join in, and we hope you'll join in and talking with our special guests, that you put your hand up, and then Noosh or myself or Thomas will try to identify you, and we'll try to give everyone a chance to contribute who would like to do so. So in today's topic, we're very pleased to have 3 great guests who are all experienced in different areas of leadership. And perhaps I could just ask them to introduce themselves one by one, starting with Fiona.
Yes, I am EMBO director. By background, I'm a researcher in stem cell biology. My interactions with EMBL and EMBO actually go right back to when I was a PhD student, and I first attended an EMBO workshop here in Heidelberg. And most recently, I was on the SAC for EMBL. So although this job is new for me, it feels very much like coming home, and I'm really enjoying it.
Fantastic, thank you. And Kristina?
Hello, I'm Kristina Djinovic Carugo. I'm a structural biologist. I have started as a head of EMBL Grenoble in July 2022. Before that, I have been at the University of Vienna in the Department of Structural and Computational Biology, which I had been heading for 13 years. And bit before, in the late 90s, previous millennium, I was actually at EMBL Heidelberg as a staff scientist for 4 or 5 years. So I am a member of EMBL, but also an alumnus, if you want. And actually, it was this past experience with EMBL that actually made an important factor, was an important factor in decision-making process to join EMBL again.
Thank you. It's great to have you here. And last but not least, Remco.
Hi, everybody. I'm Remco Loos. I'm a scientific senior director at Bristol Myers Squibb, based in Seville, Spain. So my background is computer science, theoretical computer science even. And after my PhD there, I moved to EMBO EBI in Cambridge, where I got versed into kind of the more biological side of the computational sciences. So I spent there quite a while as a postdoc and then a staff scientist. Then I moved into biotech, working on developing DNA-based nanodevices. And for the last 6.5 years, I've been working kind of in a more industry context, leading a computational research group.
Thanks, Remco. So as you see, we have a great group of invited speakers today who have experience with leadership in different aspects of science, from institutions, international organizations, and industry. And we are looking forward to an exciting discussion. And I know many of the members of the audience also have thoughts and direct experience of leadership themselves. So Fiona, perhaps if we could start with yourself. Taking on the role as head of EMBO is obviously a huge undertaking, and we were very pleased when Maria Lepton came as a guest almost exactly 2 years ago. And we had a fascinating discussion that Maria led on the topic of the importance of basic science. We're 2 years down the line. EMBO's under new leadership, but many of the challenges and opportunities still remain. How has it been taking over the reins of EMBO?
Well, Maria, of course, is a very hard act to follow. I see her a lot. She's constantly in and out of Heidelberg in various places. But I suppose I come to EMBO with a bit of a different background to Maria, and I've been involved in science publishing as an editor for many years. So one of the things, I suppose the thing that I really like about leading EMBO is the different components of the organization. So our mission is to support excellence in the life sciences. As you'll be aware, each year there are elections for new members, and we have now, I think, over 1,900 really great life scientists around the world. And they're not passive. We recently did a survey about EMBO and we got really strong response from them. So I like leading EMBO because we know that we've got this huge resource of our members. We have science publishing arm, and we spend actually 2/3 of our budget on funding postdoctoral researchers, and we have a very active program in connecting young investigators, helping them to form networks. We train them in lab leadership. Many people around the world have done that course, and so I think what is interesting about EMBO is that it's a mission-oriented organization, but it has these very diverse aspects, and they can be really synergistic when we can join the dots between our different activities. That's really exciting, and I hope show leadership to other organizations around the world who are also concerned with, for example, careers or publishing. So it's about multitasking, I think.
So you obviously have a job as director that involves multitasking, and very interested to hear more about the publishing side in a few moments. But I just wanted to ask, our societies in many different ways are having to wake up to the importance of representing inclusiveness and diversity in a more overt way. Is that something as an organization that EMBO is also thinking about? And if so, how do you go about trying to increase diversity and inclusiveness?
That's a really interesting question. I've obviously been really done a lot to try to support increased participation of women in science. I should say my career up to this point has been mainly in the UK. And I suppose I came to EMBO feeling that women had made great progress, and we now needed to focus on diversity more generally. But I've really come to realize in the last few months that the situation for women scientists is not equal across our different member states. And also, when we talk about diversity in an EMBO context, actually what's really important is to make sure that researchers in different countries have the same opportunities as in the best funded, largest countries. So I've really had to sort of switch my thinking about diversity. I no longer think that, we've done well with women in science. I think there's a lot more to do. And having a sort of country perspective on diversity is interesting, one I'm just really trying to get to grips with. It's all about listening to what people need and want.
I mean, the issue you started by raising, which of course I think we would all agree with, about leading excellence in science, which I think has to be at the heart of our activities, but it also could potentially create an issue or a problem, depending on how you define excellence. I think maybe opportunity for excellence may be one way of defining it. And the reason I'm saying that is, as we would, or as you would wish to increase diversity, if you have a rather superficial way of measuring excellence, how many papers have you published in Nature or Cell, equal opportunities don't exist across the member states for achieving this, access to funding, career opportunities. How do you go about, well, first of all, would you agree with that issue of keeping excellence as of great importance, but not allowing it to distort the importance of being representative?
Yes, I would defend the aspiration for excellence, but I would say that there are not quantitative measures of excellence that can be applied across the field, and really being able to spot and nurture talent and excellence wherever you find it is really, it's important. If we don't embrace that idea, then I think it's I'm a bit frightened for the future of academic life science research.
And how best to do that? There's a new election just started to elect members of EMBO. When the EMBO members look at the candidates, how in practice can you balance these things?
Well, you will have no doubt read the pretty explicit instructions from me about, don't just click on your friends. Take time to think about the way people can contribute more generally. And I'm actually laughing because I think the website this year looks a lot better than before. And it's very easy and intuitive to explore what a candidate has done outside of the conventional parameters of scientific excellence. So I'm sure you'll tell me if you disagree, but I think there's really very little excuse to vote with. Yeah, it's hard to miss the information we provide now about the candidates.
Okay, I'm sure that's a topic that there are other people here who have got opinions on. I encourage them to contribute and come to Fiona with that. Are there any specific targets that you have, either this year or over the next 3 or 5 years, for how you want to see the membership evolve or the organization develop? Yes, I mean,
one of the things that we conducted last year and into this year was a survey of the life sciences. We got 3,500 responses. 1,400 were from people that we would describe as members of our community, and the rest were from outside. And there's some really, top hitting comments that come up. So Noosh and I actually have discussed a strong appetite for mentorship in all of its different forms, including peer-to-peer mentorship. Research integrity is something which everybody is concerned about. But I feel as practitioners of science, we have a responsibility not just to talk about it, but to try and help there. And I think, in terms of publishing, as we go fully open access, we need to be aware that it's complex, making sure that not only can everybody read the work, but people can afford to publish their work. So there's some really interesting challenges there.
Yeah, I agree. And I'd really like to unpack a bit more the whole issues surrounding publication technology and how that exists. Just since you brought up the issue of mentorship, it's something I also feel very strongly about and have participated, still do, in some active mentorship programs. But I know it's something that's also dear to the heart of the alumni organization. And I wondered if Fatima might like to comment on that.
Actually, I'd like to bring a couple of issues up. Well, first a comment and then also a question to Fiona. So my comment is about the issue of, journal metrics and evaluation of people by journal metrics. I've been a member of the EMBO long-term fellowship panel for several years, and now lately we have kind of shifted away from mentioning journals when we evaluate candidates. And I must say that it has been really a very nice move. It's easier than what you may imagine. And it provides really a much, overall evaluation of the candidate. I think it's possible, and I think it's really a very nice and positive action.
Thank you. I mean, if I can just come back on that, EMBO was very involved in DORA at its outset, the Declaration on Research Assessment. And what I find really frustrating in different contexts is that, you know, organizations that have signed that declaration are still evaluating based on what journal you've published in. And I agree with you, it's not difficult. You just have to, well, frankly, read the papers. You know, you have a responsibility to assess a candidate in the round rather than try and quantify what they've done.
Yeah, and even though it's possible that you may not read, you know, be able to read the whole paper if you have a lot of applications, you can read, you know, the titles, the abstracts, and you can get a sense of what the person has done. So I think it's really nice and a good thing for EMBO to sign DORA. And now, personally, every time I have to write a reference letter for someone, I state, you know, I'm a DORA, you know, signer, and I'm not going to mention journals. I'm just going to mention science, no? So and you know, I think it's fine. It's not so difficult.
Yeah.
And then I forgot what was the other thing. I have a question for you, Fiona. I mean, do you have kids?
Yes.
Because I want to, you know, one of the things for women to become leaders, there are, depending on the stage of life that you are in, there are two main problems. So for young women in, you know, with reproductive capacities, the question is how to coordinate a family, you know, having kids and coordinate a life family with jobs. And I wanted to ask you how, in your personal case, how you've done it. And also for more mature, you know, women like me, you know, is how to actually have a successful lab, how to have the time to have a successful lab, and on top of that, all the other things that you have when you are in a leadership position, like your position now, you know. So how do you manage your time?
I mean, if I was being very self-critical, especially today, because I've been on a lot of meetings, I think I'm doing too many things and I'm not doing them well enough. But that's the sort of thing that we generally keep to ourselves. So I think there's a risk of being overcommitted. In terms of children, I suppose I was lucky that I became an independent scientist at a young age. So I already had tenure when I had my children. I have the ability not to worry about home when I'm at work and vice versa. I'm confident that my children turned out okay, despite, you know, despite having kids. And I think, I'm not saying for a minute it's easy, but a sort of fundamental biological principle is that it takes a sperm and an egg to make a baby. And I would argue that encouraging men to take parental leave wherever they can and to talk about it really helps. And today it was the cell biology group leader lunch, and it was quite natural to see one of the male group leaders online, baby over his shoulder, contributing. And so women can be positive role models, but really encouraging and helping men to be good parents, I think, is super important.
Yeah, I couldn't agree more, Fiona. Thank you so much.
Fatima, I know your husband very well, and he told me that your success was all due to him doing everything for you. So I'm sure.
It's true.
Fatima, I was also, Fiona also brought up the issue of mentorship, and I know that's something you've been discussing intently. I wonder if you could just comment on that.
Yeah, I think one of the things that I was asked by Nush the first time I took the chairperson position at the Alumni Association was, so what would you like to build here as your kind of legacy? That when you leave the Alumni Association, leave the chair position in the Alumni Association, you look back and say, hey, this is my, little piece of jewelry that I've been able to, contribute to the association. Then I immediately said a mentorship program. A mentorship program. We are such a large community and we have such a diversity of professions that we can really serve as mentors. We are from so many different countries. We are really, something to take advantage on. And a mentorship program, I think, to mentor not only alumni to alumni, but also EMBL, people that are not alumni as well. That would be really great. And the program was launched, already last year, and it has been quite successful, I think, and it's going to be, fully be operational, next year. So I hope you all take advantage of it. We can do any type of mentorship as you need, because we are really diverse. That's the key thing. And I'm really very happy, and I have to thank, Peter, that he's not with us anymore, but took a big, took this as his personal also commitment. So it was really, really very nice to have him on board with this. And also the members of the board that contributed to this. So I'm really very happy how this has turned out.
That's great, and I would again encourage Fiona and everyone else online and who have participated in the Coffee with EMBLs. There's a lot of experience around this virtual table, even from myself in mentoring people and with some success. And I think this would be a great thing for the Alumni Association to contribute to, and perhaps Fiona also can help, the alumni community can also help you and your aspirations through EMBO in providing these activities.
We're actively engaged with Nush on this very topic. So I agree, it's a great initiative.
Okay, so let's watch this space. And if we can take up the topic of publishing again, I think there's a number of things. It would be great to hear a bit more about your thoughts about this. Like many aspects of our society, publishing is an area that has evolved considerably during my working life as a scientist. Some of your other participating competing journals or other journals also explore other models. Lara, I'd like to bring you in. I think you have an interesting point about this with respect to eLife.
Yeah, thanks so much, Angus. Yeah, I really like the discussion between you, Fiona, and Fatima right now about the publishing systems, because I'm one of the early career advisors at eLife, and some of you might have seen that eLife just proposed a new publishing and peer reviewing model 2 months ago by now, where basically exactly what you were discussing should be achieved, that there's no or the importance is not the assignment to the journal or the impact factor of the journal that a manuscript is being published in, but instead the focus should be on the actual peer review and exactly what you have been discussing. Like, it would be important to actually know the content of the journal, and eLife is proposing that instead of saying, yeah, we accept or reject papers, we instead provide like a very succinct and a standardized what is now called an eLife assessment, right, together with the paper. So you basically have the paper title, the abstract, and then you have this like assessment that in a like standardized manner is being written like in a collaborative manner together between the editors and the reviewers. And this like publishing model is already available now for people who want to trial it, and will be like fully implemented from February next year on. So I just didn't want to let this discussion pass without briefly mentioning that, because I think it's a first step into the direction of thinking, okay, can we actually, you know, potentially even get completely rid of journals in the long term?
Believe it or not, it's really great that you come in with that point, because I was wanting to highlight specifically the initiative that eLife was taking, partly because I was planning to submit something through this vehicle. And there can be such, many of us have experienced in professional science problems where it can take 1, 2, 3 years to get a paper published, because someone decides to be a gatekeeper and an anonymous referee obstructs, and maybe for good intentions, but still has an almost distorting effect. And you know, there is at least one school of thought that let's get the information out in the public domain and let people read it, and then if it's rubbish, well, that will be very negative for the people in the authors of the paper if they publish low quality and continually publish low quality work. But don't censor it. Don't have, no, you can't even expose it. But I understand there's a tension with the journals wanting to publish peer-reviewed, high-quality stuff. So I'm really interested, Fiona, as an experienced publisher, as well as I know an extremely successful author who publishes. You've sat on both sides of the table, and I'm sure experienced both these things.
Yes, I mean, there's just, I think, one particular thing I wanted to highlight. I was just at a meeting that was convened at Janelia Research Campus by Ron Vale and the ASEP Bio crew. And the focus was discussing refereed preprints. And I'm on the board of BioArchive and MedArchive, and so have always been in favor of preprints. But what we're seeing now is that as a preprint goes through a review process, which may be linked to a journal or may not, then on BioArchive or on eLife, those reviews are posted. You can then post the response of the authors, and at some point the paper may be published in a conventional journal, or it may be in eLife or Wellcome Open. But for me, there are two important things about that. One is we no longer need to think of publishing as binary, you know, unpublished data, next day published. We see it more as a continuum. But one of the things that we did in EMBO was to say, for our postdoctoral fellowships, one of the eligibility criteria is a first author paper. And we said, no, it can be a first author paper, or it can be a first author refereed preprint. And we started this in April. So from April to August, only 3 out of 522 applications met the eligibility criterion by that process. But we all know how postdocs have really been damaged by struggling to publish in a particular journal, and then they miss a fellowship deadline and they're out of it. So I think initiatives like eLife, refereed preprints, and other ways of actually giving scientists credit for unsolicited peer review. The whole science publishing landscape is changing radically. And so far, I would say all for the better.
Is there any evidence, objective data, to contribute to the question of whether the sort of anonymous peer review of the traditional process really does ensure higher quality in the resulting publications in the end?
I mean, it's difficult. This was discussed actually at the Janelia meeting, because of course, if the identity of the reviewer is always publicly available, that would suppress valid criticism. Or equally, if I see that Angus Lamond has slammed one of my papers, I'll go after you. So I think in all, if we think about it very honestly, we have to protect reviewers so that they can be critical, but equally in a process. And one of the things I liked when I was deputy editor of eLife was that the consultation among the reviewers, which actually regulates pretty well inappropriate comments. So I don't know the data on anonymous versus anonymous peer review. The only thing I would say is that for me personally as a scientist and people in my lab, we need to be able to say at some point, this project has gone as far as it's going to go with these contributors. And so the idea that you will have a piece of work that you're embellishing over the years at the moment is, I've not heard people who are that enthusiastic about it. Whatever the unit of sharing your data is, you want to be able to say, that's it. This is, as a PhD student, this is the work that I did. I've moved to another lab. I'm doing this now. So, okay. Yeah.
Perhaps, Kristina, I could ask you to come in also at this point. And speaking maybe specifically about the field of structural biology that you're then leading in Grenoble, how have you seen publication of structural biology changing? Do you think it's changing? Is new technology affecting the size of groups who publish, or who then takes responsibility for publishing?
Oh yeah, the way of publishing structural work has changed, I would say, really notably. If I compare, for example, how I published the work I did for my PhD compared to what's been done now. In particular, because nowadays one needs to combine structural data with other functional analysis, both with the molecular biophysics approaches, with biochemical approaches, as well as combine it with in-cell functional data. And this then becomes naturally a multi-partner endeavor. Because it's of course very difficult that everybody can do, that one person or one lab can do everything. So it's really a multifaceted study nowadays. So yes, this has really changed dramatically, because at the early days, structure was enough. Now structure is only one part of a let's say, study to really understand structure-function relationships and understand how the molecule works, and to relate that to how the molecule works at, let's say, molecular and chemical level, and to relate that into its function in the cell.
And do you think that affects your ability as a leader of an institute to select young scientists, or it doesn't have to be a young scientist, but people you want to bring in as a group leader, where perhaps it's harder to understand their specific contribution to a larger project?
I think it does. Oh, you mean how does one assess a candidate? Yes, no, that becomes a little bit more complex indeed. One hopes to understand this a bit better through the, let's say, interview process. But on the other hand, one can also then think the other way around. What kind of person would I like now to bring in the institution to complement the expertise, the know-how, and also to be able to, with his or her research project, capitalize of what else the institution offers in order, because of this multifaceted approach or need that nowadays is requested.
All right. So maybe I can jump in with a question, because of course, we all heard last year about the marvels of AlphaFold, artificial intelligence, and how this is rapidly moving the field of structural biology. So I wanted to understand, what is your view of this? How do you think, especially now that you are getting at the helm of such an institution, how do you think this will change the landscape for structural biology? How are you gonna come to a new model, and how are you gonna incorporate this into even more successful science?
Yes, no, I will start with saying that we just had a fun EMBL structural biology retreat, which we hosted here at the Grenoble, and we of course also discussed quite much together AlphaFold and its impacts, together, of course, with colleagues from EMBL EBI who actually contributed to it. We believe that let me now speak for myself, that AlphaFold has already changed the way we are doing structural biology. It is bringing us, I would say, to a different level. We actually have, say, on the one hand, hot start, because we have structures available with which we now can really generate hypotheses that then need to be tested experimentally. And this is, of course, it does help, or perhaps avoid some complicated experiments to get the initial structures, but these initial models from AlphaFold are an excellent vehicle for generation of hypotheses, and of course they have to be validated.
Yeah, so no, that's great, and I think it is fascinating that the artificial intelligence as a tool is quite rapidly permeating into many fields. So actually, one interesting parallel between the previous discussion that we had and this discussion is that last week we saw this new algorithm for building text that is called ChatGPT. And, you can clearly see that, as a tool for producing the snippets of text for actually a paper. And so it's fascinating how, we are basically changing a little bit the paradigm from having to figure out or building these things using artifacts and experiments to having somewhat of a simulation as based on data and then testing and refining. So it's a little bit of a flipping of a model. So yeah. I don't know also if Fiona wants to jump in on the paper part on this, but I think it's a general trend.
Even may I just comment?
Sure.
Definitely artificial intelligence is, of course, can be very successful, but it needs to have good learning data set. And in case of AlphaFold, that was in fact the case, because it had protein structural database that has in a few days is going to have 200,000 structures, which are very well curated, very well tested, checked. And this is what AlphaFold is learning and learned from. Therefore, the good databases and big enough databases are essential. Therefore, it's not necessarily easy to say, let us have an artificial intelligence on topic X, for example, on protein-protein interactions prediction, because the database might not be, or the available data might not be easily collectible, I would say.
Yeah. I think that one element here is that I guess scientists have to be very, very aware of this, because now, everything is getting so refined and so removed from the single scientist that sometimes it's very difficult to actually judge that. AlphaFold was I think, a particular case, because it was actually the success was the database. In other situation, it becomes a little bit more blur as a situation. So it's more difficult to actually make a judgment call and say if even the prediction is a good prediction and it's worth actually probably spending the money to make an experiment on.
Absolutely. Absolutely. No, experiments will remain essential, at least in structural biology.
Yeah, so I don't know, maybe Remco wants to comment on this and
sure,
starts to get into the discussion.
A lot to talk about, a lot to think about here. AI makes a lot of difference, right? And AlphaFold has really been a success story there. But as you say, very much based on data, and also kind of based on knowing a ground truth, right? You know whether you got it right or not. And I think, for instance, in drug discovery, there's a lot of talk of AI, and a lot of people think we should be doing AI. A lot of snake oil salesmen going around saying, well, hey, we can solve all your problems. But it's important to distinguish between kind of classical AI, which the chatbot, for instance, is a good example of. It's something that can do things that us humans can do, but with a computer, which is amazing. But if we really want to understand biology, say, we need our deep learning models to do more than what we humans can do, kind of go beyond current human understanding. So that's where things become a lot more difficult. And I think there's a lot of credit to, let's say, AlphaFold to come up with completely new models to do that, to go further and really, I don't know if you think about functional genomics, those kinds of things, understanding the biology, then one of the things we're hitting the wall against, and not just us, kind of the whole community, is how do you know you got it right? Typically there is no gold standard in what a gene expression profile should look like. So I think there's a lot more to be done there. But yeah, it's exciting because there's a lot happening. And I think this also ties into the publishing discussion, because especially in this field, like AI, machine learning, preprints kind of rule the world. By the time the paper actually comes out, the research has already been kind of absorbed by the community, cited regularly. So I think preprints are really making a big difference there, and increasingly in biology, in experimental results, things are out there before they kind of go through peer review and the whole process. So I think that's generally been a really good thing to avoid kind of what Angus referred to as kind of things getting stuck in the pipeline, even through kind of extraneous elements such as reviewers and other obstacles.
Yeah, I mean, and I think, we have seen this in COVID times, right? Where, speed was an issue. I mean, certainly we couldn't afford to spend 6 months a year into the peer review. So probably for the benefit of getting it maybe not entirely right, but out fast, then preprint played a big role there. Yeah, it's actually, I mean, one thing that I find fascinating, it's always this comparison when we talk about preprint with the, maths as a field. They had like this very, upfront model, and the discussion is going on when everything is out in the public domain. And I would maintain that, of course, there it's a little bit simpler because, maybe there's less money involved. But I mean, it's an interesting concept because then, the community is actually contributing. So you have many different things that are going on. I mean, you're probably losing also the concept of ownership of the research to a single group because it becomes share ownership. So the one question could be, why a model like that couldn't work for publishing, while it probably works for most of science, where people are sitting on top of each other, people tend to be open, everything gets transformed very fast. So a lot of, I think, interesting food for thought on this side.
Thomas, I have a question for you, but it would be great if Remco and Kristina and Fiona and anyone else could comment on it, because I don't know the answer, but I was trying out this chat GPT tool. It's difficult to say, especially this time on a Friday. I was testing it out this week, and it was just, I couldn't believe it. It was just remarkable. I asked it to write me some Python code for doing something. It wrote it, it worked. I asked it to write a summary, suitable for putting on a website, just to see, okay, if I gave it a few simple prompts, just like maybe talking to a PA or something like this, they just came back with a remarkably well, I was blown away by how good it was. I guess my question then is, I didn't try this, but if I said to ChatGPT or a future improved version, write me a paper about whatever you want. Here's some data. Just write me a paper, and then I send it to EMBO Journal, and Fiona publishes it, and then someone comes on Pub here and says, this guy Angus Lamond, he's a complete fraud. It wasn't him who wrote it. Is that cheating?
Well, yes, it is. You've stolen the intellectual property of your computer. But you might be interested in, there are lots of AI applications in publishing, but one that we've been playing around with internally, which I think is really funny, is that you can arrange things so that inflammatory comments by a referee get smoothed out. So so it's like the substantive criticisms are still there, but the stuff that causes a lot of offense can just be removed automatically. So we're not implementing that at the moment, but there are lots of really interesting things you can do. Another thing is selecting referees. There are already companies who will provide referees' names based on an algorithm to search databases. And actually, you could argue that that is more fair and inclusive in terms of finding referees than relying on an editor's personal knowledge.
Yeah, absolutely. I mean, it's very an interesting point, the one that you're doing about smoothing out inflammatory comments, because it's like you're trying to remove the emotion and try to get to the essence, which is useful. I mean, sometimes we are clouded by emotional judgment in these things, but now if you can remove that and see the point, maybe there is a point sometimes. I see a couple of hands up, so maybe we can give the word to Ivo that was first, and then Jonathan.
Yes, thank you for allowing me. I just would like to touch a little topic that basically I'm an ARISE fellow, and I've been with the EMBL for 1 year, and it's great to be listening to people that have some experience, and it's very interesting especially to what has been said on structural biology. I attended at the EBI a symposium on this recently developed algorithm, and one of the interesting areas is the fact that in structural biology we could obtain more information about structure based on experimental evidence, something that is very difficult to do with variants, because there is no data on variants, and for that there is this already established field of research called proteogenomics that you probably are aware of. And one of the questions that I had in mind is the fact that I don't see many people at EMBL involved in analysis of data in proteogenomics. And I was wondering whether, considering the very good applications in basic research and biomedical applications, whether these fields will be somehow taking off in the next few years. But this is just a matter of conversation. Thank you.
Let's give Kristina the word. She can certainly feel that.
Yeah, thank you. Thank you. We have actually been discussing this topic over or after as a result of the review. There was maybe 20, 25 years ago this boom of structural genomics, which was an effort of many consortia, many labs to basically determine structures of proteins, like list of proteins. That could be structures of all Escherichia coli proteins rather than structures of all membrane proteins, or so without any, let's say, working hypotheses behind. And these, many of those structures actually then remained there, deposited in the protein structural database, but never analyzed, never published, because there was no hypothesis, no biological question behind. So if we are doing, if you want to do structures in a more, let's say, massive way, then this needs to be done. We believe really with the hypothesis behind, with the biological question behind, not just across, because the structure alone will not tell you everything.
But has anybody tried to do this with, for instance, with AlphaFold? This is my ignorance, but did people try and simply screen AlphaFold by providing, completely artificial sequence of amino acids to see what it will come up with?
At the moment, so there is a database released by EMBL of 200 million structures based on basically deposited sequences, and recently there was released a database of 600 million structures predicted by AlphaFold based on metagenomics data. So there is basically a lot is out there.
It's like an old style screening. Yeah.
I actually asked a question to people that were presenting their work at this meeting recently, and they said that basically the most important thing is to have basically the protein sequence, including these variants, with already some structural data. So there it comes, because in order to be certain that there is a variant, a substitution, just to say a substitution, you need to combine in proteogenomics basically the genomic evidence and also confirm that using proteomics data. And this is the complicated thing, because there are no very, the development of algorithms is ongoing, but there's no very reliable way of being 100% sure that this variant is real. You could have the genomic mutation or SNP basically, but then again, whether that is expressed at the protein level is another issue, and putting the two together in proteogenomics is still, is something, a matter of time and effort, and it's a brilliant point to be able to establish that more. And I think an organization like EMBL has, probably the human factor or the idea to put that forward as an area.
So Ivo, I think this is getting a bit too technical for a wide audience, probably. So if we can get a very short reply from Kristina, then we leave a bit of space for Jonathan before we move to the.
I will be very short. So of course we would all like to see AlphaFold predicting also structures of variants. This at the moment is really not yet there. And this is also what the DeepMind people, that is the authors of the algorithm, actually claim themselves. Second, just brief comment to Thomas. Prediction of artificial sequences is not something AlphaFold is expected to be able to do, because it relies on the amino acid sequence alignments behind it. And since this being an artificial sequence, it wouldn't have this information that would guide it at hand.
Okay, that's cool. It's good to know. So
Sorry,
we bring in.
Sure. Just a very quick comment. As Kristina said, so AlphaFold 2 is not really made for these kind of small changes. There are other programs, kind of Rosetta Fold, etc., that are more tailored to that. And there's another area which is really quite interesting, but still getting our head around, is kind of protein language models. So kind of taking the sequences, and these models kind of learn evolution just by kind of being fed the sequences of existing proteins. So we're still kind of trying to get our head around what these models are really learning, but these are kind of interesting developments as well in that sense of applying deep learning to protein, both structures and sequences.
That's great. So this is a nice segue, because now we will focus a bit more on Remco, but I would still love to give the word to Jonathan, because may I have a comment on this part. So let's make it quickly, because we want to explore also the last part. Thank you.
Yeah, I only had a really quick comment coming back to Angus's point about using ChatGPT. I hope I remembered it correctly, for writing, and my comment is this actually reminds me of a coffee with EMBL session we had long ago about AI and intellectual property. But the fact is that many organizations use medical writers or ghost writers to write manuscripts. So I'm not sure that it would be so far to have an AI-based system that can take, all the literature that's out there and pull it together into a paper, presumably with the scientists providing proper interpretation of the data that's included.
Yeah, I mean, sorry, Thomas, if I could just
Sure.
to respond very, very quickly, just to say, that's really what I was thinking about, Jonathan. It reminded me of that also. And if you haven't tried it, these generative pre-trained transformer models, the GPT models, are truly remarkable. And I think they're a game changer to do. So I was just thinking, if I asked one of my students or postdocs, hey, help me, write or make a first draft of a review on splicing or something I was interested, and they wrote it, and then I edited or commented on it, and we published it. I don't know it's that much different than me starting off by saying, hey, ChatGPT, write me a review on splicing literature from the last 10 years. Then I edit it, send it to Fiona, and she accuses me of fraud.
I think it all has to do with databases, right? Because, I mean, you would argue that your database, the database for ChatGPT has to be better than your postdoc to start with. Then, it's still a language model, I guess. So
maybe they both search the internet, though, and fetch the relevant literature. But anyway, I don't want to distort. I mean, it's about leadership. So I guess it's a good time to, ask about leadership. And Remco, I mean, maybe you could comment on your experience in moving from academia into industry, and whether you see close parallels or major differences in leadership between these two environments.
Sure. Well, first of all, I'll say industry for kind of many people in academia is kind of this strange beast that is far outside. I personally feel myself very much part of the scientific community, right? We do research. The end goal is slightly different, but we're very much kind of trying to solve similar problems. We publish, we work in the same world. What I think is also kind of similar is part of our job as a leader is kind of building a team, mentoring, and people and developing them, developing talent. So I think that is very similar across both spaces. Where I see a big difference is the academic world, kind of the rules of the game are very well established, right? You publish, or you in your field, you try to gain some prominence. You basically have an audience of peers that you try to convince of your views of the world of science, and your success and scientific leadership kind of is defined in that world. I think in industry, what I've found is I spent a lot more time leading others or convincing people in other areas to change things. There are limits what, for instance, I can achieve by doing excellent analyses in my group. If our aim is to develop new drugs, then quite often things we need to improve are outside the realm of my specific area of expertise. It is kind of working with others and getting a big organization like BMS, for instance, to do things better. For instance, AI can be leveraged in many ways to get better at discovering drugs, or quicker or more cheaply. But that requires the organization to change. So it's not just me doing good research in AI. It's kind of convincing other people that this is the way to go, and other people need to change their way of working. So I think that is a big difference in industry, where you spend a lot of time outside your area of expertise, trying to get people to come along with you and change things.
Cool. Maybe a question that I have is, how do you see the relationship between industry and academia? I mean, there's many points where these relationships are perfect, right? You know, you take on where the basic research in academia ends, or you pick up from there. But there are some situation in which things are not as smooth. I mean, in a sense, there's like an asymmetry in founding, for instance, which means that there is also an asymmetry in recruiting people or being successful at this. How do you see these themes? I mean, is something that concerns industry, or?
Well, I think about it slightly differently. I don't think there's necessarily a conflict. And I think sometimes that academia wouldn't lose by kind of one way to think about it, and this is a very partial view, but the rule or the aim in academia is often is publishing papers, right? And so you often find a nice rounded story that you can tell, publish, great. What we try to achieve is we publish papers as well, but we also help to make decisions about, and these are often very important decisions, right? Whether we spend millions on a clinical trial, whether we expose patients to a certain drug which can have risks. So I know the level of certainty that is required is maybe slightly different. The paper, there are lots of papers, as we know, that if people try to kind of reproduce the results, they don't reproduce. It's something we can't really afford to do on our side. So sometimes looking at things this way and kind of saying, hey, is this evidence strong enough to really base some real decisions on? I know a bit more of that mentality wouldn't hurt in academia. And at the same time, I think there is a lot of complementarity. I don't think they're competing worlds. I think in the end, it's science done by scientists who are excited about science. I think both worlds have their pros and cons in terms of freedom, in terms of funding, in terms of other things. But I think in the end, we're all part of a big scientific community where in the end, we all want to do the same thing, which is, I know in our case, kind of understand biology good enough to, or well enough to, in our case, to make drugs that work. In the other cases, to really describe reality, nature as it is. But I think, I don't really feel there's a big gap.
Yeah, I mean, I didn't mean to bring it into some sort of a conflict. There's probably that's maybe not what I really meant. On the other hand, I mean, I think, you know, the scientists, or, you know, the academic scientists, they're always, you know, a little bit disconcerted about, you know, little resources and, you know, having to deal with, you know, funding problems and all this kind of stuff, where industry, of course, with a different model doesn't, of course, suffer from that in terms of at least financing the research. So, I mean, I you know, let's say a metric of this could be that, you know, a lot of people probably go from academia to industry, but the other way around flux from industry to academia is not is not the same. So, I mean, you think, I mean, what I'm trying to get at is whether we can see, we can think of a different model that perhaps for fundamental science, the one where you, of course, necessarily do the opposite that industry. So you go out and explore, even if you're taking maybe too much risk and stuff, whether there is another model that can be taught that bring more partnership between, you know, maybe institutional funders and industry in making sure that you have a fertile ground for the fundamental science before you go to academia.
Two quick comments. First of all, I don't think it's true that industry has infinite money, right? It's a risky proposition, and yes, there may be money for research, but there is risk involved, and it's expensive to develop drugs. The other thing is, again, industry and fundamental research are not contradictory. DeepMind is a company, right? And and I think there's a lot of things we do which qualifies as fundamental research. So in that sense, I think now there is more flux from people who've been in industry to academia, but quite frankly, I think it may be a bit of a silent indictment for the reality of working in academia. If people go to industry and never come back, it might be that maybe working conditions are better, maybe even scientific conditions are better in practice in industry.
Well, I think it is open for discussion, but I think it's really great to keep having these conversations, right? Because you want to make the best. As you said, you know, they're complementary endeavors, and the goal is always, you know, furthering progress and getting new medicines or new treatments or new technologies. So I think it will be great to simply keep on discussing this thing. So I don't know how well we're doing with time, Angus.
I think as usual, time has got away from us, Thomas, which is one of the good things. It's always a surprise how quickly the time goes. We're actually getting close to the end. I wonder, as we approach the end of another year of Coffee with EMBL, when we have these speakers here, perhaps we could just go around the table also with yourself, Thomas, Fiona. Fiona, if we could start with you again. Leadership is also about inspiration. What's your parting thought for 2022? It's been a difficult year for many people. As a leader of science, how do you inspire the people who work with you and in your organization?
I mean, it has been a difficult year. I think many leaders have spent a lot of time being really positive to try to encourage everybody else that we're through it. And I suppose my parting message is just rediscovering the joy of being with one another in person, the joy of random conversations when you're both trying to get a cup of coffee. So really just loving doing science in all of its different ways. And I think inspiring future generations of scientists that it's such a wonderful career. It's a privilege actually to be able to do what you love.
That's a great answer, and a good attitude for mentorship also. Kristina, how do you inspire Grenoble?
Yes, so what I think is one of my really important roles here is to really enable people and put them in the best possible environment to do their science. That means from the environment to have the infrastructure, to have the support, to have the atmosphere, the environment, as well as to, if and when needed, accompany them into the next career steps, or mentor them, of course, if needed. And I believe that in these times, with the inflation hitting, where we have to be mindful of budgets, so having highly motivated people is really very important. And this is what I'm going to be trying to do, and supporting them as much as I possibly can.
Thank you, Kristina. Remco, as a leader in industry, how do you inspire and keep your workforce motivated?
Well, I'll just echo Fiona's words that it's been tough, right? Being apart. Science is a communal activity, and kind of bouncing ideas of each other is an essential part of it. And these meetings can do some of it, but actually being in person together is a completely different proposition. So one of the big joys this year has really been kind of getting together with the team and everybody, and even people we hired during the pandemic, and we can now kind of really get to know in person. So I think that's been a big joy and a big motivator for all of us. I think I know they're difficult times in many ways, but they're very exciting times in others, right? We talked about AlphaFold, which was big news a year ago and is now part of our daily scientific lives. The ChatGPT, and another thing that points towards the possibilities of new technologies. There are things like spatial transcriptomics coming on that really give us better ways of connecting the dots between different things. So these are really exciting times to be a scientist and to make big leaps forward. So I think that is very motivating, not just to be part of that ride and to contribute the pieces of science that drive it forward. And I know the way things are going, I can see kind of significant advances in the next 5 years in how we treat cancer, how we treat diseases. So I think this is a fantastic time to be on the roller coaster of science. So I think anyone who's excited about science is easy to motivate at this time.
Okay, thank you. And maybe Fatima, I could also ask you as the leader of the Alumni Association to comment on how you inspire the Alumni Association and everyone in your sphere of influence.
Well, I hope the association agrees that, well, I've always tried to get to promote a very friendship and participative atmosphere, and I think participation of everyone in what they can contribute, even as small as it can be, it's really important. So I think I would like to continue doing so in the little time that I have remaining in the association, and I'd like to continue perhaps promoting communication between all alumni, right? I think this is very important. And now that we have come back to kind of quasi-normal again, I hope to see you all in Heidelberg next summer, right? Yeah. And yeah, I have to admit that probably there are occasions in which I've not been so inspiring, because sometimes I'm a bit tired and people may look at me and say, hey, I don't want to be, as tired as this woman is. I hope, yeah, we can, I can manage better my time in the future. Yeah.
Thank you, Fatima. Thomas, how can you inspire us?
Well, I don't know if I can inspire you, but I was thinking now that perhaps one thing to ask to the chat GPT is actually whether he or she or it is going to take a break during these Christmas holidays, because it's always also a good time, at least for humans, to take a break. But I can second what Remco said. Is a very exciting time to be in science. It's great. The pace of discovery, knowledge is, I think it's exponentially increasing, and it's difficult to keep up, but we really hope, I mean, every scientist, I think, hopes that we will see the follow-up of all these in terms of treatments, in terms of new knowledge. I mean, I guess, in a year we went from having the fastest vaccination for COVID to having the first proof that fusion is working, and maybe we will, maybe in 30 years solve our problems with energy production. I mean, how can you, compare this with anything that was in the past? It's incredible.
Noosh, how about you? Sorry, I see Fatima's got her hand up, but Noosh, perhaps we could hear how do you inspire your team, and what do you find inspirational?
Sorry. I find the community inspirational. I think if you work with people that inspire you, you have to first be inspired to then inspire others. And I find that what we can do, I think I'm just so excited about what we can still do in this community, it's just the people and the vision. That's inspiring, then that's all you need.
Excellent. Fatima, you've put your hand up. Would you like to add something again? Oh, you're muted, Fatima.
Yes. No, I just wanted to ask the same question to you. You're there asking everyone, but no one asked you. So
that's true.
How have you inspired your people this year?
I was hoping you wouldn't ask. I think what I like to do is encourage people to try to be the best version of themselves, and not let themselves get too focused on negatives or judging themselves based on other people. I think the more important thing is to look at yourself and try to say, okay, there are, today there are most of the people here smarter than me. That's fine. That's great. It's a pleasure to speak to you, but I can still try to do the best I can and learn from each of these events or other events, so I can do it a little bit better in the future. And so I think for me, I really share Nooshi's comment and many of the other ones, that I think being part of a community is a community of great people is one of the most enjoyable things, and therefore inspirational for me. And I like to keep myself, sometimes I have to try hard, but not to focus on negatives, but always to try and find a positive. And, we've heard that Thomas and the other speakers, yourself, highlighted so many exciting positive things that are available ahead. Let's all focus on those and not on the negatives that we see that dominate the media, because the media loves negative stories and problems. And I think it's our job to focus on solutions and excitement, and to communicate that to our colleagues, but also to society. So that would be my message.
Yeah, I don't want to steal the last word to Angus, but after, I think, 1.5 years of working with him, I can testify that the way he inspires people is that's what I say always, he's some sort of a real Highlander, not only because his parents are 100 years old, but also because he has enthusiasm, drive, warmth. Is every time he said it, I mean, every time you meet him, you think that you could do better, and he's really pushing you to be the best version of yourself. So be in touch with Angus and you'll be inspired.
That's true, especially in 2 days' time when he has a birthday.
Not the 100 one.
Happy birthday!
Well, we can't, in Germany, you can't congratulate them before.
No?
Okay. But we will be thinking of you on the 18th of December.
Well, that's thank you all. I'd like to thank everyone in the community for joining us in these events. I greatly enjoy them and find them very exciting. Please do let us know who you would like to join us, who you would like to lead discussions in future as speakers, and which topics you would like to explore. And I think there's a lot of inspirational opportunities ahead for us all to get together at future coffees with EMBL. So please do come back. Please do share your ideas. And I think on behalf of us all, we want to wish you a very happy holiday wherever you are, and have a nice time. I hope you can all spend some quality time with your friends and family, and come back next year full of inspiration for the next set of Coffee with EMBL events. Yes.
Thank you very much. And thank
I
you.
have my EMBL,